Hey folks, Mike Johnson here. If it's got wheels and an engine, you're in the right place. On this channel, we dive into car repairs, maintenance tips, and everything you need to keep your ride running smooth. If you're into cars and want to keep learning, don't forget to hit that like button and subscribe. It really helps the channel out. All right, enough talking. Let's get into it.
The vehicle is equipped with a number of sensors which are used to monitor all kinds of information. Among them is the knock sensor, which is a listening device located near the engine that detects vibrations caused by engine detonation or knocking. P0327 is one of many fault codes associated with a faulty knock sensor. If your analysis tool displays this code, read on to find out more about symptoms, probable causes and other relevant information. What does fault code P0327 mean? Fault code P0327 means knock sensor 1 circuit low input, bank 1 or single sensor. It is triggered when the powertrain control module, PCM, detects very low voltage readings from your vehicle's main knock sensor circuit. Note that the voltage value may vary depending on the make and model of your vehicle. Vehicles subject to code P0327 include various models of Chevrolet, particularly Chevy Silverado, Nissan, Subaru, Toyota, and Audi. What are the possible causes of the P0327 code? P0327 is a generic code. This means that it is supported by different makes and models. However, diagnostic and repair procedures may vary depending on the make and model of your vehicle. Here are the possible triggers for a P0327 code: faulty knock sensor circuit problems with the PCM. A. G. Software needs updating. What are the common symptoms of P0327? Symptoms related to P0327 may vary depending on your vehicle. Here are the most common ones you should look out for: engine warning light, engine pings on acceleration, engine may show no visible symptoms, fluctuating engine speed. In some cases, the engine may show no noticeable symptoms related to code P0327. As a general rule, once your check engine light comes on, be sure to have your vehicle checked by your mechanic. How to diagnose P0327? With many possible causes, it usually takes an expert to be able to identify the underlying cause of an OBDI code. However, this doesn't mean you can't attempt to diagnose the problem yourself, especially if you have automotive repair skills and know-how. How to repair the P0327 code? The solution for the P0327 code varies depending on two main factors: what triggered the code, and the make and model of your vehicle. This can make it difficult to determine the right solution if you're unfamiliar with automotive repair or OBDI codes in general. Not only will you need to identify the exact cause of the problem, but you'll also need to make sure that the solution is right for your vehicle. Once you've diagnosed the problem that's causing it, the next step is to research repairs that have worked for other vehicle owners who have encountered the code due to the same problem. The exact repair may differ from vehicle to vehicle, so be sure to limit your search to similar vehicles. For example, replacing the affected knock sensor would have resolved code P0327 in some Chevy vehicles. Of course. When performing any type of work on your car, be sure to check out online auto repair resources to make sure you're guided accordingly. You can also get an all-data subscription for individual vehicles for detailed factory repair information. And don't forget, always consult your owner's manual when carrying out DIY work on your vehicle. What are knock sensors for? To begin with, it's important to understand what engine knock is, and what the knock sensor listens for. Some old-fashioned drivers call it valve knock, but it has nothing to do with valves. What are knock sensors listening for? When a cylinder is healthy, there will be no knocking. But with the ultra-lean mixtures used in modern engines, combustion temperatures tend to be higher. And when the heat of combustion is transferred to the carbon deposits on the cylinder head and piston crown, some of the carbon can become hot enough to start the combustion process before the spark plug ignites. When this happens, the resulting multiple flame fronts can come together and impact the piston crown as it moves upwards with sufficient force to produce the ping sound that signifies detonation. This is partly because, as the carbon begins to harden the piston crown and head, these layers take up space in the combustion chamber. So compression is increased and the combustion event is hotter than normal. In the old days, when ignition timing was adjusted by turning the distributor, if the timing was too far forward, a similar thing would happen, Only it was called spark knock, as the spark actually occurs before it's supposed to, and the resulting combustion event knocks on the piston head as it rises. Fuel with a lower octane rating than that for which the vehicle is designed can also cause detonation due to the speed at which the fuel burns. If 87 octane gasoline is used in an engine tuned for 93 octane, the gas will generally detonate under load. Similarly, if 93 octane gas is used in a vehicle tuned for 87 octane, cold stumbles may result. The type of engine knocking that the sensor listens for is measured in thousands of cycles per second, kHz. How knock sensors work: engineers determine the engine knock frequency and the crankshaft rotation window at which each cylinder will detonate. Any ping that the ping sensor hears that doesn't match the expected frequency or doesn't occur within the expected window for one of the cylinders is ignored. This is also relevant insofar as the ECM to PCM can determine which cylinders the ping is coming from. The good news is that, with coil-on-plug engines, the timing of each cylinder can be monitored separately, so if only one engine pings, the ignition timing of that particular cylinder can be delayed just long enough for the ping to stop. As for sensor operation, depending on the severity of the measured knocking, the sensor will produce spikes from 0 to 4.5 volts. Even on a normally running engine, there will be some knock sensor activity, and the ECM to PCM knows it. When the motor is running and the knock sensor is not producing any type of signal, code P0327 is set. Some motors will have the knock sensor screwed to the side of the motor block. Knock sensors in different vehicles: some early knock sensors receive a 2.5 volt supply from the motor controller which changes when engine knock is detected, and if this voltage is reduced to 0 or increased to 5 volts, a code is set. Some V engines will have two knock sensors in the valley below the intake, and on these engines, the knock sensors are in rubber grommet-covered wells. If a grommet leaks, water will flood the sensor and ruin it. This often happens on 4.8 to 5.3 to 6.0 LCV V8S. Some engines will have the knock sensor bolted to the side of the engine block, and sometimes knocking will actually be detected through the coolant on the side of the engine cooling jackets. A faulty knock sensor should not be taken lightly as it can damage the engine.